Welcome back to my channel. Let's continue solving problems from the 27th Philippine Math Olympiad qualifying stage. We are now on part 3, problem number 1. John wrote down the numbers from 1 to 128 in binary. How many ones did he write? For this solution, I'm assuming that you already know how to convert numbers in base 10 to binary. Alright, so how do we solve this problem? We can do casework. We can divide the solution into cases depending on the number of ones used in the binary expansion of the numbers from 1 to 128, because some of these numbers will have only one digit 1 in its binary expansion, others will have two ones, others will have three ones, and so on. So for case 1, what if there's only one digit 1 in the binary expansion? Take note that the maximum number of binary digits 0 or 1 that you can use when you convert these numbers in binary is 8. You can easily verify that one by converting the number 128 into binary. So let's start with 8 blanks. The 8 blanks represents the position of the 1. For example, you can place 1 in the leftmost blank and then fill in the remaining blanks with zeros. So this one corresponds to this binary number. Another is that we can also place 1 in the fourth blank and then fill in the remaining 4 blanks to the right with zeros and ignore the 3 blanks to the left of 1. So this one now corresponds to this binary number. So now we see that there are 8 choose 1 ways of placing the number 1, meaning 8 choose 1 possibilities for the positions of the digit 1. And for each of these possibilities, there's only one digit 1 that is used. So the total number of ones used for case 1 is 8 choose 1 times 1, which is equal to 8. Now for case 2, what if there are two ones in the binary expansion? Again, let's start with 8 blanks. But here we have to be careful because we cannot put a 1 in the leftmost blank, or else we will have a binary number with a base 10 equivalent which is greater than 128. For example, to illustrate, let's place 1 here and then another 1 in the fourth blank and then fill in the remaining blanks with zeros. So this binary number will have a base 10 equivalent of 144. You can easily check that. But since the maximum number given in the problem is 128, so we cannot really place a 1 in the leftmost blank. So let's ignore the first blank and then just focus on the remaining 7 blanks. Alright, so we have 7 blanks left. For example, we can place the first one on the second blank and the second one in the fourth blank, fill in the rest with zeros. So we have this binary number. Another, we can have these placements, fill in the remaining blanks to the right of the first one with zeros, then we have this binary number. Now we see that we can place the two ones in the remaining 7 blanks in 7 choose 2 ways, right? And for each of these possibilities, there are two ones used. So the total number of ones used for case 2 is 7 choose 2 times 2, which is equal to 42. So for case 2, we have 42 ones total. Now, we can do the same process. Just take note that we can do the same process for the remaining cases, but we take note that we cannot put a 1 on the leftmost blank. And for the remaining cases, we must have these results. For case 3, the total number of ones used is 105. For case 4, that's 140. Case 5, 105. Case 6, 42 ones. Case 7, 7 ones. So the total number of ones used is just the sum of all of these numbers, and so the final answer here is 449 ones.